Hey guys! Welcome back to the laboratory. In this video, we are looking at the group 7 elements, commonly referred to as the halogens. By the end of this video, you should be able to identify the main properties of the halogens, explain the different reactivities of the halogens, and use displacement reactions to determine the order of reactivity of the halogens. So, let's go! The halogens are located in group 7 of the periodic table. As we do not study much of the transition metals at GCSE level, these 10 groups in the periodic table are often omitted, therefore explaining why the halogens are commonly referred to as the group 7 elements in GCSE text. With that being said, do note that the halogens may also be referred to as the group 17 elements in other sources. Being a group 7 element means that all of the halogens have 7 electrons on their outermost electron shell. As a result of having the same number of electrons on their outermost shell, the halogens have very similar chemical and physical properties. To begin with, all of the halogens are toxic and corrosive and must be handled properly to avoid harm. They all exist as diatomic molecules, whereby each molecule contains 2 halogen atoms that are joined together by a single covalent bond. They have relatively low melting and boiling points, and these values increase as you move down the group. This is because of the increased strength of the intermolecular forces as the molecule increases in size, therefore requiring more energy to be overcome. Similarly, the densities of the halogens also increases as you move down the group, with fluorine being the least dense of the group and astatine being the most. As well as the trends in their physical properties, there are also trends in the chemical properties of the halogens, namely that their reactivities decrease as you move down the group. This trend in reactivity is explained by the interaction between subatomic particles within the atom, namely the protons and electrons. Because of the overall positive charge in the nucleus of an atom, there is a natural force of attraction between the nucleus and the electrons, seeing as they are of the opposite charge. Now remember, when an atom of an element is reacting, it is doing so because it wants to achieve a full outer shell. The halogens achieve this full outer shell by gaining 1 electron on their outermost shell and forming -1 ions. As the atoms of the halogens increase in size, the distance between the nucleus and the incoming electron increases too, and so the attraction between them becomes weaker. As the attraction weakens, it becomes harder for the halogens to gain this electron and therefore react with other elements. This explains why the halogens become less reactive as you move down the group. As it becomes harder for the halogens to gain this outermost electron, it also becomes harder for them to react. We can use the concepts of Wi-Fi to better help your understanding of this concept. Generally speaking, the closer you are to a Wi-Fi router, the stronger your connection, and thus, the easier it is for you to connect. However, as your distance from the router increases, the connection strength weakens, therefore making it harder for you to connect. In this diagram, person A would find it easier to connect to the Wi-Fi router because they are closest to it. This analogy can be used to reflect the interaction between the nucleus and the incoming electron when an atom of fluorine reacts, therefore explaining why it is the most reactive of the halogens. In contrast, person C would find it harder to connect to the Wi-Fi because they are furthest from it. This analogy can be used to reflect the interaction between the nucleus and incoming electron when an atom of astatine reacts, therefore explaining why it is the least reactive of the halogens. We can use displacement reactions to determine the order of reactivity of the halogens. To achieve this, each halogen is reacted with a solution of another metal halide. If the halogen is more reactive than the halogen in the metal halide, then a displacement reaction will occur. For example, when bromine and iodine are reacted separately with potassium chloride solution, neither of the halogens are able to displace the chlorine from the compound. The observations indicate to us that chlorine is more reactive than bromine and iodine. When chlorine and iodine are reacted with potassium bromide solution, a displacement reaction only occurs with chlorine, indicating that bromine is more reactive than iodine, but less reactive than chlorine. And when chlorine and bromine are reacted with potassium iodide solution, the iodine is displaced by both chlorine and bromine, indicating that iodine is less reactive than both. We can use this information to determine the order of reactivity of these three halogens. The halogen that displaces the most halogens is the most reactive, and so on. Chlorine displaced bromine and iodine from their compounds, and is therefore the most reactive in this list, followed by bromine and then iodine. This order of reactivity is confirmed by the ordering of halogens in the periodic table. Here's an example of a past paper question that I'd like for you to attempt to test your understanding of the content covered in this video. Pause the video and take your time to work it through. Press play once you're ready to check your answers. Chlorine is a halogen. Chlorine reacts with potassium iodide solution to form potassium chloride solution and iodine. Explain, in terms of electronic configurations, why chlorine is more reactive than iodine. As always, the question has provided us with a plethora of information that we can use when writing our answer. The information in the second line of this question details that chlorine is able to displace iodine from its solution, therefore informing us that chlorine is more reactive than iodine. Because we know that the reactivity of the halogens decreases as you move down the group, we also know that chlorine must be above iodine in group 7 and is therefore a smaller atom. Now we can collate our knowledge and write an answer that will award us the full 2 marks for this question. Our first mark is awarded for highlighting that when the halogens react, they do so by gaining an electron. Our second mark is awarded for stating that because chlorine is a smaller atom than iodine, the electron that is gained is more strongly attracted in the chlorine atom than in the iodine atom, therefore making it more reactive. So, how did you do on this question? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!